Okay, welcome back. We're in section 3.4. This time we're going to try and get a handle on our data, much of the way that we did graphically back in chapter 2, only this time we're going to use some data descriptions, something called the 5-number summary and box plots to help us do this. We want to get it's going to give us a rough sketch of the distribution of our data and what we can tell about that data right here. So we're going to use Excel to help us get the numbers that we want. We're not going to do it by hand anymore. And we're going to go through and we're going to organize this data and come up with a box plot. So with that in mind, let's talk about our distributions. We know that a distribution can be uniform. Right? We see uniform distributions being the type where all the data is pretty well distributed evenly to each of the different areas in the data set. We can have a bell-shaped or symmetric curve. We right-skewed and left-skewed data sets as well. So when we recall that what these look like right here, this gives us some sort of idea of what we're looking for. These numbers right here, Q1, Q2 and Q3, the way to think of these are they're called quartiles. It sounds a lot like quarters, and it is exactly that. 25% of all of the data falls less than quartile 1. The next 25%, so the bottom 50% of the data is less than quartile 2, which is really the same thing as the median. 75% of the data, that's 25% above the median all the way up to this next level. 25% of the data falls within quartile 2 to quartile 3, so 75% of the data falls less than quartile 3. So quartiles tell us a little bit about our data set, right? If the quartiles are relatively close together, most of the data is bunched in the center. If the quartiles are relatively spread out, it tells us something about the distribution again. If there's a little bit of a larger spread between any two quartiles right here, we know that there might be a skew. So quartiles are actually a pretty decent way of telling us something about the distribution of our data. The way we would get a quartile by hand is if we have our data set, we could arrange that data set in increasing order and then determine the median. Then divide half the data set into two halves, and the bottom half, the half of the bottom half and the half of the top half form our quartiles. So the first quartile is the median of the bottom half. The second quartile is our median overall. And the third quartile is the median of our top half, if we could describe it in any way. Now, they give you a nice process here for finding a quartiles, that is arranging the data in increasing order, finding the median, dividing the data set into two halves, finding the median for both of those top and bottom halves, and then summarizing the results. There's also interquartile ranges. For example, if we're looking for the difference between the first, third, and the first quartiles, we can look at that difference, and that might tell us something a little bit about how far spread out. As we saw, if we see that that difference changes, we might end up with data that has a little bit of a skew. But our 5-number summary goes like this. We find the minimum observation and the maximum observation. We look for our median and our other two quartiles, and we arrange them. And if we get this 5-number summary, it's going to tell us a little bit more about our data set. One thing that we do want to know is that our lower and upper limits of data sets are usually within 1.5 or 1.5 plus or minus of Q3 of the interquartile range. So we're looking for upper and later data sets that are within 1.5 of those differences here. All right, what we're going to do is we're going to open up the data set from Canvas, and we're going to check out the POTUS, P-O-T-U-S data set, and we're interested in the variable height. So we're going to find our information, for example, the mean, the median, and the standard deviation. I'm going to show you how Excel does this very quickly. And I'm going to show you how Excel will also find all of these values right here, the minimum, the quartiles, and our maximum, as well as the range. So let's go through and do that. I'm going to open up Excel. Here's our change. If we go to the course modules right here, if you open up from course modules, lecture 3. I'm going to put our data set in there, right? Or you can always go down to the very bottom here. I have all of our data sets set up right here. You guys should be able to access these things, right? There we go. So we're going to go down, we're going to open up POTUS, P-O-T-U-S, here it is, right? So here's that data set right here, POTUS. Now, you won't see these. These are labels I put in, but what these are the data on our presidents of the United States. So in fact, this is an entire population. Well, we see that we have data for age, days, years, height in inches, and height of our opponents, I guess, when we were running against somebody. So 188 is the height, right, in centimeters for Washington. And we go all the way down to President here. We're going to consider this because at the time this book was published, that was our data set. So what for our entire population of presidents. So what we're going to do is we're going to find out how we get a mean. Well, for our data set, I'm going to go over here and I'm going to enter in. Whenever you enter in a formula in Excel, you start with the equal sign. Right, so we're going to type in our equal sign right there. And we're going to type in a formula. Now the formula that we're going to put for finding our mean is in Excel goes like this, A-V-E-R-A-G-E. And you'll notice that there's a list of choices right here. The one we want is the very top one. It says average. So if we double click on that, you'll notice that there's a parenthesis that gets inserted right here. What it's looking for is for you to enter in the data range from which you're going to get this data. And we're going to use the data range from column E here for height. So I'm going to go to height, and I'm going to highlight my cells all the way down to the bottom right here. There we go. Right, no blanks in there. And then I'm going to close my parenthesis. So you see what it does right here. It puts in the formula average, E2 to E39. In this case, that's our list of presidents. So we hit enter. And there's our average height, our mean height of 179.68 centimeters. Median is pretty easy too, right? We're entering the formula equals median. Right, there's only one formula for that, so we double click on that. And again, we're going to enter in our data set, a data range from E2, and we can just type it in if we want, colon, right? So we use a colon in there, 2 dots, one above the other, E39. And close that data set right there, that range, and that gives us our median height of 181. Standard deviation. The standard deviation is found by entering this formula, STDEV. And you'll notice that we get two choices here. Dot P stands for the population standard deviation. Dot S stands for the sample standard deviation. Our data set makes up the population of all the presidents, so we're going to substitute, we're going to use the standard deviation .p command right here. We're going to put in our data range again, that goes from E2 to E39 in this case, and close the parentheses. And there it is. There is our information about our standard deviation. So let's go ahead and enter this on our handout right here. Here are the formulas that you can use. It's average, median, and standard deviation. In this case, it's P for the population. It would be .S if your data set was a sample. All right, let's find our other values right here. I'm going to show you the commands for minimum, quartiles, and maximum. So let's go back to our data set right here. For the minimum, the command is equals MIN. Very easy. We put our parenthesis right there and we enter in our data range from E2 to E39 again. 163 looks like our minimum right here. Quartile 1, or let's go down to the maximum here. The maximum equals MAX. Right? MAX. And then, of course, we just want to choose maximum E2 to E39. Enter our data set, and there it is. 193 is our highest. Quartiles. The command for quartile goes like this: equals QUARTILE. Now there's two choices right here. we're going to choose the one that says inclusive. We want the inclusive data set of from 0 to 1, all data points included right here. So we're going to include that. And we're going to enter in our range E2 to E39 again. Oh, too few arguments, right? This is one of those commands where you need to put in an extra thing right here. So in this case, you'll notice that there's a little instruction down here. It says array. So we entered in our array, but we forgot to enter the quartile. So we're going to hit comma, and we have our selection of first, second, or third quartile of the maximum value. Let's go ahead and select the first one. Double click on that, hit enter. Ah, there it is. Quartile 1 is 173, right? 25% of all the presidential heights are less than 173. Okay, quartile 2. Quartile 2 is going to be our median, right? So we could actually just enter in our median, or we could enter in the quartile. Quartile. We're going to be inclusive. E2 to E39. And we want quartile 2. And that's 181, right? We see that's the median, same thing. Quartile 3 equals quartile. And we're going to choose the inclusive one again. We're going to be E2 to E39. Choose 3. There we go. All right. So our quartile range right here follows this data set right here. What they were saying about the range, let me go ahead and let's enter this information into our handout sheet here. There we go. What we were saying about range is that we take the maximum minus the minimum, 193, 193 minus 163, that gives us 30. Okay. And then what we would want to do is we would want to go ahead and use this information as our answer in problem 4. Okay, so not too bad so far. We're well on our way towards the end of this thing here.